Now we're going to look at wave properties, starting with reflection and refraction. So we'll start with reflection and start sum of refraction. We have to describe the reflection and transmission of waves at a boundary between two media. When energy goes from one media to another, some of the energy is transmitted and some is reflected. The more different the media, the stronger the reflection and less will be transmitted. If the light is not affected in any way as it passes, then effectively this object is invisible because the light does not deviate from its path, and we'll see an example of that. It basically depends on how the path of the light changes due to its change of velocity. In other words, it depends on the refractive index of each medium. If the refractive indices of the mediums or media are the same, then there will be very little change. In other words, you won't notice the difference between one medium and the other. So this affects the speed and the direction of the light. So, why reflections occur? This happens when there's an abrupt change in the medium. For example, when light reflects off glass or water. Glass and water are very different from air. There's quite a difference in the refractive index. Here we have an example. You see the glass reflects a lot of the light from the sun here. Here the water is reflecting much of the light from the buildings over here. And this is a picture where you have a flower which is reflected in the water here. Now this is an interesting experiment where you have a Pyrex rod is put into an oil which has exactly the same refractive index. Here we have a Pyrex rod is going into glycerol, and they have the same refractive index. So the light does not deviate when it goes from the glycerol to the glass. So therefore we are not able to see it because it provides no disturbance in the light. So effectively it's invisible when it's in the glycerol. You need to know about reflection of a single pulse. So we have a wave on a string. This is the wave coming in on the string, and it hits a barrier. If the barrier is fixed, then it will be reflected back in the opposite direction. So the incident pulse, the string is fixed. When it comes back, it is inverted. It goes to the other side because it's been fixed there. Effectively, as this wave comes in, it pulls up on where it's fixed to the wall, and because it pulls up, the fixture pulls the wave down and makes it go in the opposite direction. It's an example of Newton's third law. So it's reflected and inverted, called a wiggle wrench, though it isn't actually, it's an instruction to wiggle the wrench. So what I'll do is wriggle it. No, you can't see that so well. I will reduce the damping. We'll try again. Notice it gets reflected on the opposite side. It gets inverted. Let's try again. Oh, there we go, pulse. Let's make a pulse. It gets inverted on the other side. Let's reduce the damping even more. Pulse again. It gets inverted. Inverted. This is because it's fixed. What happens if it's loose? Restart. If it's a loose end, where it's able to move up and down, it will be reflected, but it will not be inverted. Notice it reflects on the side. It gets inverted on this side because here it's fixed. what do you think would happen if there was no end? Does it get reflected if there's no change in the medium? We'll start, shall we? The reflection, there is no reflection. There's no change in the medium, so the wave continues.